Good afternoon, everybody. Welcome to Monday afternoon of Chem 170 with your host, me, Dr. White. All right, we got a lot to do today, so I better get started. But I hope you all had a nice time since we last met. All right. Last week on the 9th, I posted the following, and it's a reminder. This Wednesday, the 15th. Oh, today's Monday the 13th. Oh, wait, that's only Friday. By the way, Friday the 13th has been very lucky for me. But anyways, on this Wednesday, the 15th of February, I will be giving test number 1. Test number 1 has 10 pages. Relax, there's a lot of room for you to write things in for, and 14 problems. Some of the problems have multiple parts. I have never will give multiple choice questions in Chem 170. It covers alkanes, and I could have put down here hydrocarbons too, alkanes, cycloalkanes, alkenes, double bonds, alkynes, triple bonds, and aromatic compounds. These are all things I've covered. Test number 1, point breakdown. There are 13 points general knowledge, like how many bonds to carbon. Next, nomenclature, 45. There are 2 main nomenclature questions. One is give the IUPAC name for the following. The other is here's a name of a compound, organic compound, draw the structure. And next, 47 points on reactions. All but one problem will be give the organic product or products for the following. And if you notice, it adds up to 105. So there's 5 bonus points. Now, the way I do bonus points is I don't specify a certain problem being a bonus problem. No, I just have the whole thing add up to 105 points. Now, at the end of our class on this Wednesday, I will send out an email to all of you with the password for the password protected PDF file of test number 1. And you'll be able to download that from D2L. You'll have from 4 p.m. or even earlier, well, you'll have until 4 p.m. on the next day, Thursday the 16th, to take test number 1 and upload it to D2L as a single PDF file. Oh, that reminds me, I'd like to thank everybody for handing in your lab as a single PDF file. I've had trouble in the past where some students just don't want to do it. It's caused me a lot of extra work, which I don't want to do, but all of you did successfully. Sometime tomorrow, I'll post the scores for your labs, the grades. All right, so test number 1 will be this Wednesday after class, and you'll have until Thursday, 4 p.m. Take it and upload it as a single PDF file. Now, if we go to that's not what I want to do. Let me change the view to D2L as a student. If you logged in, this is how it looked to you. Click on assignments. And you'll notice, test number 1. And here's the PDF file. Now, this is a password protected PDF file, and you can download it now. But on Wednesday, after class, I'll send out the email with the password, and then you'll open it up. As you can see, I keep on putting this in. All of you did it correctly, how to do a PDF file instructions. And also, one of you used Cam Scammer, which looked real good. And hopefully you used the free edition, didn't pay money for that. So what you'll do is download it, take it, upload your answers. Now, if you do not have a scanner, you can use your camera to make a PDF file, which some of you did. If you do not have a printer and a scanner, you can write out the answers with the question number. You do not have to rewrite the question for test number 1 and upload it as a PDF file. So once again, this is test number 1, and it'll be this Wednesday. Now, couple things. One, in a little while, I'll do the world famous review for the next test, which is test number 1, our first test. And I would like to remind you, every question on my test and the final, it will always be true. I've gone over the concept behind every question at least twice, usually a lot more. Also, doing the practice problems will help you do well on test number 1 and also the rest of the test. So, any questions about test 1? Going once, twice? You don't want to turn your mic on, you can use chat. All right, one other thing. What was I going to say? Oh, if we're doing this face-to-face in a classroom setting, students get 55 minutes. Most students, if you've studied, are done in about 40 minutes or less for test number 1. So my test, if you studied and practiced, you should have no trouble finishing it in under an hour. However, I'll give you as much time as you need. I'm not going to be there to time you, but I will say this. I have put things in my test to know if a student cheats. And unfortunately, Dr. White is very clever, me, and they work. So please don't cheat. If you do the practice problems study, you'll do well. All right, since there's no questions, it's time for me to do my world famous review for test number 1. And if you go to the lecture section of D2L, I almost said the wrong school, computer system, to D2L, you'll see in the lecture system near the bottom, there'll be the file test number 1 review. So everything you're going to see on here is in that file, but I'm going to go through it now. All right, things you should know for test 1. What is a hydrocarbon? It's a molecule with only carbon and hydrogen atoms. You should know, what's a saturated hydrocarbon? Well, it's a hydrocarbon, so it's a molecule with only carbon and hydrogen atoms, in which all carbon-carbon bonds are single bonds. You should also know what's an unsaturated hydrocarbon. That's a molecule with only carbon and hydrogen atoms, and that contains one or more carbon-carbon multiple bond. And you could have also say it contains one or more double or triple bond. Now, I have the definitions of alkane and cycloalkane. I'll never, ever ask that on a test, but I put it down here just to be, I used it. All right, now you should know how to draw alkanes and cycloalkanes. Remember, on test 1, your friend will be how many bonds to carbon? 4. How many bonds to carbon? 4. 1, 2, 3, 4 bonds to carbon. And next, let's talk about IUPAC nomenclature rules. You should know how to use them. And remember, I'll never ask on IUPAC. If you see it, that means the official name, but I like to say International Union of Pure Applied Chemistry. And that organization created and maintains those rules. An important thing. Sorry about that. It's not the president or his governor. 2 more. That's my Bluetooth phone. That should be the last one. All right, back to the class. All right. You should be able to identify the longest chain. We've done this. You should know the alkane names 1 through 10, meaning methane, ethane, and so on through decane. You should know these following alkyl groups: methyl, ethyl, and propyl carbon. At the end of 3 carbons, bonded a chain or ring. 3 carbons, center carbon is isopropyl and N-propyl. Then I only asked you to learn 2 butyls. N-butyl is to the end of 4 carbons, a straight chain to a ring or another long chain, and tert or T-butyl. And like I said, I'll be being a lazy organic chemist, just call it T-butyl. And 3 methyl groups or CH3 on a carbon bond to a chain or a ring. Now, the one thing I don't have here, which I should put down, but let me do it right now. Remember, when we draw a ring, every bend in a line is a carbon. 1, 2, 3, 4, 5, 6. 6 carbons is hexane. But since it's a ring, we used a prefix cyclohexane. So make sure for your rings, you use the prefix cyclohexane. And why don't you give, what's the IUPAC name for this compound I just drew? Your turn. And for those of you who are suffering from potato chip and junk food overdose from yesterday's Super Bowl, well, you're not the only one going through that. Boy, that was a high scoring affair. Not a defensive game, but fun to watch. All right. I think everybody's done. My turn. So what's the longest chain? Well, there are 2 ways of counting it. 1, 2, 3, 4, or 1, 2, 3, 4, doesn't matter. There's a third chain, 1, 2, 3. That's smaller than 4. So this is the longest chain, and that's butane. 4 carbons, you should know that chart. And we have left over, oh, it's your good buddy, the methyl group. CH3 is methyl, and it's on carbon number 2. We started the other way, 1, 2, 3. Remember, you always number the alkyl groups as such that they get the lowest numbers when there's no other functional groups. And we'll get to that the rest of the semester. Now, the reason why I put this up, common mistake on test number 1, student sees, oh, this methyl group is on that carbon. I'll make that carbon number 1. And that's wrong. It even says on the screen. Why? Because only the ends this carbon or this one could be carbon 1. When you're doing a chain, a long chain, only the ends, never anywhere else, can be carbon 1. So I just wanted to point that out to you, and I did. All right, now you should know at least one real world use of alkanes. Hint, general knowledge, that could be methane or natural gas used for cooking. Oh, how many remember propane that you can use for your barbecue? Did anybody drive by a gas station and think about alkanes? Well, alkanes are in gasoline, they're in Vaseline and baby oil, and 50% of the weight of a candle is or are alkanes, longer chain alkanes. In fact, I worked for a company. When I worked for it was called Unichem Chemicals. And it got its start in the Netherlands back in the, I don't know, early 1800s, making certain chemical for candles, and they made candles. In fact, I have a commemorative candle and candle holder from, I think it was, what was it, their 150th or whatever anniversary. All right, the only reaction we went through is if you have an alkane, and it can also be cycloalkane, and you react it with oxygen, what you get is carbon dioxide and water. The heat you don't have to put down because that's not a chemical. If I ask, give the products for that reaction, it's CO2 and water. Remember, in this class, you never, ever have to balance a chemical equation. Moving on, alkenes and alkynes. An alkene, a carbon-carbon double bond, and you should know a double bond is one pi bond, one sigma bond. An alkyne, Y-N-E ending, is a triple bond. That's why you see the 3 lines. And you should know that it has 2 pi bonds and 1 sigma bond. One other thing, each covalent chemical bond, each line is 2 electrons, represents 2 electrons. So an alkene has 4 electrons, alkyne has 6 electrons in a triple bond. Now, nomenclature, double bond, alkene. Find the longest chain or ring that has both carbons of the double bond. Name it as an alkane. Drop the ane ending, use ene. A number is needed for acyclic plus cis or trans. And no number or cis or trans for cycloalkenes. And I'll come back to this in a second. For a triple bond, find the longest chain with both carbons of the triple bond, name it as an alkane. Drop, mistake here. Sorry about that. I'll have to go back and change this later on or tomorrow. But anyways, ane ending becomes yne plus a number. And one of the carbons of the triple bond always gets the lowest number closest to the end of the chain. And let's look at this molecule. The question would be, give the IUPAC name for the following, and how many carbons are in the longest chain? 1, 2, 3, 4, 5, 6. Notice I've shown stereochemistry, the bond angles. Now, if we were to put a plane here, notice I have on each carbon of the double bond the same atom or group, and now we can use cis and trans. Notice they're below the line, so that would be cis. Longest chain, 6 carbons, hexane. Drop the ANE, double bond, hexene. The closest carbon to the end of the chain is 2, and then it's cis. And here's one for you to try. Excuse me. Give the IUPAC name for the following molecule. All right, looks like everybody's done. So how do you name this? You look for what's different. Remember, when you're doing organic chemistry, look for what's different. What's not a carbon-carbon single bond, carbon-hydrogen attention, hydrogen atom. Got confused there. Get your attention like that. And we have a double bond. How many carbons longest chain? 1, 2, 3, 4, 5. That's pentane. But it's a double bond. So I drop the ANE, put ENE ending, pentene. If I start from this side, 1, 2, 3, so you have a choice. It can either be 3 or 2. You pick the lower number. Double bond starts at carbon 2. Notice here, if I had a pencil or my finger or a plane, the hydrogens are 1 on each carbon double bond, are on opposite sides. And as it says up here, trans, opposite side. So it would be trans 2-pentene. All right, next I started teaching you some reactions. And the first one was hydrogenation. You take a double bond, react with hydrogen and catalyst, you break the pi bond, and each carbon of the double bond gets a hydrogen. And that catalyst can be nickel, platinum, or palladium. And now let's have you try one with that reaction so I can illustrate an important point. Your turn. Give the organic product or products for the following reaction. 3 points each. Oh, after you take test number 1, you'll understand why I say 3 points each. Hint. Just out of curiosity, because I'm a curious person, Can you see in the left part of the screen where it says untitled poll? Okay, I didn't think you could. I can because I'm the moderator. Ooh. All right, everybody's done. What do we have here that's different that got my attention? A double bond. The rest are carbon, hydrogen, and carbon-carbon single bonds. They're just coming along for the ride. Double bond, hydrogen, nickel is a catalyst. Remember the catalysts are nickel, platinum, or palladium. And you break the pi bond. Remember there's one pi bond, one sigma bond, and each carbon of the double bond gets a hydrogen. Now, here's the reason I put this down. Do you break carbon-carbon single bonds? No. So I have 1, 2, 3, 4 across. And I have 2 methyl groups. They're still going to be there. Here are my 2 carbons of the double bond. I broke the pi bond. That's why there's only one line there. And each one gets a hydrogen. And I know there's 4 bonds to carbon. Now, if you wanted to write that as CH2 and this is CH3, you could, you don't have to. Now, the important reason I wrote this down and had you practice it is there's 2 friends you will always and always should use in my class taking a test. Number 1, you should know how many bonds to carbon? 4 bonds to carbon. The other thing that will always be your friend on my test and the final 2. Do you break carbon-carbon single bonds? No. I'll say that again in slow motion. Do you break carbon-carbon single bonds? No. Remember that. When I started teaching that after the first test I taught, the first time I taught this, everybody's scores went way up because they're doing the weirdest things, which are always wrong. All right, next, if you take a double bond, react it with halogen gas, X2, or X can be fluorine, chlorine, bromine, or iodine, you break the pi bond, and each carbon of the double bond gets a hydrogen, not a hydrogen, a halogen. Next, the first 2 are symmetrical addition. If you take a double bond, react with HX, and here X is chlorine, bromine, iodine, you break the pi bond, 1 carbon of the double bond gets H, the other gets X. It follows Markov-Nikov's rule. That is the carbon of the double bond with the most hydrogens gets the hydrogen, the other gets the halogen. And here's one for you to try. Give the organic product or products for the following reaction. And it warms my heart to see everybody doing organic chemistry on this sunny Monday afternoon. I don't know about you, but yesterday, because it got warm enough outside, I opened up the windows in my house to do a nice air out, make it smell nice and fresh and fresh. It smells fresh normally, but whenever I have a chance, I like to open the windows and let it air out. And please be patient. I try and give everybody time to finish. Everybody's finished. All right. How do you do this? Do you look for what's different, what's not carbon, what's not hydrogen, what's not a carbon-carbon single bond? Ooh, a double bond. The rest is this carbon, hydrogen, carbon-carbon single bonds comes along for the ride. Iodine is a halogen we show as X. And it could be chlorine, bromine, or in our case, it's iodine. And remember, this is one pi bond, one sigma bond. Break the pi bond, one carbon gets H of the double bond, the other gets X. It follows Markov-Nikolsky rule. And I think I told you, I still remember it when I took organic chemistry. Our instructor taught us another way to remember Markov-Nikolsky rule is the rich get richer, the poor get poorer, or them that has it gets it. We're talking about hydrogens. So we now have to look at the two carbons double bond. This one has two hydrogens. This one has one. Which is the larger number? Isn't the math hard in my class? And hopefully you pick two. You don't break carbon-carbon single bonds. Markov-Nikolsky rule says the carbon with the most hydrogen gets the hydrogen. This one, the other carbon gets the halogen. In this case, iodine, the halogen counts as one bond. I know there are 4 bonds to carbon. And I put in my hydrogens, and that's that. If you had them reversed, I mark it wrong because you didn't learn Markov-Nikolsky rule. Now, if you take a double, oh, I should point out, let me go back to this one again. If this were a problem, let's call it B, some of my best students always write the general reaction underneath the reaction they're working on. Some of my best students in Chem 170 never write the general reaction underneath. You don't have to, whichever way works for you, but you do have to learn that general reaction to be able to apply it in this type of problem. All right, we take a double bond and react it with H plus, that means acid catalyst, and water. Think of water as H and OH, and you break the pi bond, one carbon of the double bond, former double bond, gets hydrogen, the other gets OH, the hydroxyl group. And here again, it follows Markov-Nikolsky rule. The carbon with the most hydrogens gets the H, the other carbon of the double bond gets the OH hydroxyl group. All right, now, we talked about, notice I say we, I talked about, you listened and watched. We have a triple bond, which is 2 pi bonds, and 1 sigma bond. We reacted with hydrogen. Now we've got this bracket, the letters X and S and closed bracket. And that means excess. Organic chemists are lazy. This is a way we don't have to balance the equation or look like we should, because that means I have all the hydrogen in the world that can react with anything hydrogen can react with. In this case, if you have a catalyst, which is nickel, platinum, or palladium, you break the 2 pi bonds, and each carbon of the triple bond gets 2 hydrogen. And the same thing is true if you take a triple bond, which has 2 pi bonds and 1 sigma bond, and react it with excess halogen gas, X2. X again can be fluorine, chlorine, bromine, or iodine, fluorine, bromine, chlorine, or iodine. And for each pi bond, each carbon of the triple bond gets a halogen, 2 pi bonds, each one gets 2 halogens. Now, one thing I taught you that wasn't on a slide, You have two double bonds or two triple bonds or a combination of double triple bonds. They're separated by one or more carbons. They react like they're alone. So if I were to do the following and ask, give the organic product or products for the following, I'm going to let you try this one, then I'll do it. Oops, somebody should have caught my mistake. Luckily, I did. I had an extra hydrogen. Bad, Dr. White. Oh, it was funny. I think it was 2 semesters ago. I had a student from China at the other school in my class, and she'd been in the United States for a couple of years, but she didn't know what this means. Everybody know what that means? When you're a little kid, your mother ever do that to you? Anyways, I better see if everybody's done. All right, everybody's done. So if we look at this, we look for what's different, not the mark I just put on there. And we have a double bond. Remember when I say look for what's, excuse me, what's different, look for what's not a carbon-carbon single bond or a carbon or hydrogen atom. Double bond. Oh, there are 2 of them there. And we're reacting with excess. That's what this means, excess chlorines. And I have a double bond. I know this general reaction. And if you have a double bond, which is 1 pi bond, 1 sigma bond. Remember, sigma bonds, single bonds, you don't break. Nuh-uh. But pi bonds you break and they're fun. And therefore, you break carbon-carbon single bonds. No, so I have 1, 2, 3, 4, 5, 6, 7 carbons. I better end up with 7 carbons. And here are my 2 carbons of this double bond. I break the pi bond. Each one gets a halogen, chlorine. And then I have these 2 carbons of this double bond. I break the pi bond. Each one gets a chlorine. That's why you need the excess. And that's how you do it. Again, when double or triple bonds, more than one in a molecule, are separated by more than 1 carbon or 1 or more carbons, they act independently. By the way, that's not true for aromatic compounds, though. But we talked about that. And that's not what I want. This is what I want. Speaking about aromatic compounds, we talked about benzene. Benzene is an aromatic compound, 6-membered ring that can be thought of as 3 conjugated double bonds, alternating single, double, single, double, single, double. And there are 2 ways of writing that, or you can do the conjugated pi electrons with a circle. When you have a methyl group on there, that's toluene. Now, let's look at something very important. If I were to ask you to draw the structure of benzene, and you wrote that down, that's wrong. That's cyclohexane. To draw benzene, there are three ways you can draw it. The two resonance keculiforms, or to the localized pi. I like these just because I think it looks cooler, but this would be correct on test too. So remember, for benzene and toluene, anytime you have a benzene ring, you have to show the double bonds or the circle, or it's cyclohexane, and it would be marked wrong. It was a mistake a couple times during time my students have done, and they've lost a lot of points. So don't make that mistake. Now, when you have di-substituted benzene or toluene, the methyl group counts as one of the groups, we use the prefix instead of numbers, ortho for 1,2 di-substituted, meta 1,3, para 1,4. And later today, I'll be going through the aromatic problem set, and we'll go through some of these. Now, at this point, I introduce you to some new substituents that could be on a ring, and I've only done it for aromatic. Chlorine, Cl is chloro. F, fluorine is called a fluoro group. Br, bromo group. Iodine, I, iodo group. And then another new group, NO2, and that's a nitro group. Now, the first reaction I showed you, and the key thing with aromatic compounds, and for this class, the reactions are always going to be for benzene, is you don't break those double bonds, because then you lose the aromatic stability, aromaticity it's called. And it doesn't want to do that. So it doesn't. And we have what's called electrophilic aromatic substitution, where one of the hydrogens on a benzene ring, remember we don't show hydrogens on a ring, is replaced with something. The first reaction, take halogen gas, X2, and for this you need a catalyst, FeX3, where X can be chlorine or bromine. That's all I've ever seen it in real life. And you replace one of the hydrogens with a halogen. Now, I mentioned when I taught this to you that when there's something on the ring already, it's called a director, and then there are a number of possibilities of what product. I'm not going to be teaching directors in this course because I like to spend more time on things that are more important to you, like fats and oils, carbohydrates, proteins, alcohols, the good stuff. Not to say this isn't good, but for this class and your future, we don't have to get into directors, but we will do one lab. And because of that, there are only two reactions I can ask you for the first one. When X is chlorine or bromine. Next, if you take nitric acid, HNO3, and sulfuric acid, you'll put a nitro group, NO2, on a benzene ring. And because I'm not doing directors, this is the only reaction I can give you. Next, if you take, by the way, don't forget, students say, oh, NO3, I'll put an NO3 up here. No, it's NO2. Nitro group is NO2. Next, if you take sulfur trioxide and sulfuric acid, which is H plus catalyst, you'll sulfonate it. Put a sulfonic acid group on there, SO3H. And this is the only reaction I can ask that, because again, I'm not doing directors. And we'll learn way down the road later in the semester that putting that SO3H group allowed organic chemists to make the laundry detergents you use today. You use Tide, Cheer, All. Those are the three main ones, I think, or a house brand from either Costco or does Walmart have their own house brand? I use All. They all use, it's necessary to have a benzene ring with a derivative of a sulfonic acid group. Derivative means something made from that. And the final reaction is Friedel-Crafts alkylation. Take a benzene reactor with RX. R can be anything with carbons and hydrogens, and aluminum trihalide, X is chlorine or bromine. You do that very special thing. You make a carbon-carbon single bond, and the bond from the ring to the R is to the carbon atom in R that had the halogen bonded to it. So let's take a look at this one. And as I said on test one, there's one synthesis problem. And here's that one. Why don't you try this one? What two things, what starting materials would I react with aluminum trichloride to make this compound? Your turn. And like I said, this is a lot harder, but this is the fun part of organic chemistry. But I'm biased, I'm a synthetic organic chemist, and this is what I've been trained to do. And later in the semester, I'll talk about some of the things I made where someone in marketing sales, like the vice president of marketing sales, I was in a meeting and they wanted, we need a molecule that will do this and this at this price. And that was my job for many years, along with problem solving and making sure things are going well in the plants. By the way, look at your screen, the bottom, hint, 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 big hint. All right, we look at here, what's different? Ooh, we've got a benzene ring. Don't forget the bonds inside, and it's got carbons on it, an R group. And I have aluminum trihalide catalyst. X can be chlorine or bromine. And how do you do this reaction? You start with benzene plus an alkyl halide. So one of the answers here of the two starting materials is benzene. This is our R group. Which carbon is bonded to the ring? The N carbon. That will have our halogen X on it. In this case, it's chlorine. And I know there are 4 bonds to hydrogen. Let me rewrite this nicer. If you have the chlorine sticking down like here, that's okay also. And that's how you do it. you react benzene with, this is called 1-chloropropane, you will make N-propylbenzene. If I look at the clock, we went a little over, so that means it's time for a break. When we come back, if you have any questions about test number 1 or aromatic compounds, I'll be answering that. With that, let's take a 5-minute break. I'll see you in 5 minutes, and we'll continue. I'm going to get up and stretch. Time to get started. Time for me to get comfortable too. All right, welcome back. Any questions about anything I've covered for test number 1? Going once, going twice. All right. Before I do the aromatic, in case you were wondering, what you might, why do I do 5, 4, 3, 2, 1 when I edit the video and I cut out stuff before I start the official class? That helps me figure out where to do my cut. See, you're learning all my secrets. All right, let's go through the aromatic problem set, which are things you should know for test number 1. And remember I said there'll be nomenclature questions or problems, and one is give the IUPAC name for the following. And if we look on our screen, a methyl group on a benzene ring is called toluene, not methylbenzene. Now, when we have disubstituted and toluene, the methyl group is considered one of the substituents. And this would be NO2, nitro group on toluene, benzene ring with CH2, nitrotoluene. Notice it's 1,2 disubstituted, that's nitro. And if you look on the screen, 1,2 disubstituted aromatic compound is ortho, 1,3 meta, 1,4 para. And these are things you should know. And if we look at C, on carbon 1 is an ethyl group, carbon 4 isopropyl. This is a benzene ring, so it's ethyl isopropyl benzene. 1,4 is para. Now, I am not holding you to the alphabet rule, IUPAC alphabet rule for substituents. So if you'd put down para isopropyl ethyl benzene, I give you full credit. Don't tell the IUPAC, please. Shh. And if we look at D, we have Cl chlorine, chloro group. This is a T-butyl group or tert-butyl. It's 1,3 disubstituted, so it'd be meta tert-butyl chlorobenzene. That's an O, not a U. And if you put down meta chloro tert-butyl benzene, I would give you full credit. Now, when there are more than 2 groups on a benzene ring, you use numbers. You number it in such a way that the substituents get the lowest number. And here, if you notice, I have not 1, not 2, but 3 bromine on a ring. Remember, 2 is di, 3 is tri. You know something? Let me do this. And you should remember for substituents, you have 2 of them on the same ring or whatever, that's di. 3 would be tri. 4 is tetra. I've never had to use that other than a very bad joke I don't tell anymore. It's just really lame. Nothing bad about it. You can say it in mixed company. This is lame. So if we look at E, I have, if I number the ring, if I call one a bromine, it doesn't matter which one, 1. Another one is on 3. Another one is on 5. So it's 1,3,5 tribromobenzene. And why don't you do this one? Give the IUPAC name of this molecule. 3 points each. Picking on everybody who's got their screens on. Well, you can see me too. And everybody's done. And if we look, oh, we got a methyl group on a benzene ring, and that's toluene. And we have not one, but 2 chlorine, and that's chloro. And 2 is di. And what? This is always going to be 1, the methyl group on toluene. Therefore, this is 2, this is 3. So it's 2,3 dichlorotoluene. Remember, NO2 group is nitro, F is fluoro, Br bromo, I is iota. Now, the other type of nomenclature question you should know how to do, draw the condensed structures for the following. And for benzene, don't forget to put something in the ring. Now, I've made a mistake for me, not you. B would be pyrchloroethylbenzene, and you could have the ethyl group on top and the chlorine on the bottom, doesn't matter. And I forgot the di when I wrote the original problem set, but if we look at 1-ethyl 2,3-di-N-propylbenzene, remember, don't forget the lines or circle inside the ring. Ethyl is here 1, N-propyl on 2, N-propyl on 3. And if we go to the other type of problem on test number 1, reaction problems, and here's an example. Give the organic product or products. That's what I mean by a bracket as closed bracket, 1 or more products. Later in the semester, we'll do a number of reactions where you have more than 1 product. And the first one is benzene ring, Cl2, FeCl3, and this is halogenation, and you put a chlorine on there. Here we put bromine. Don't forget the lines are circle inside the cyclohexane ring, which makes it aromatic benzene. And here I have Friedel-Crafts acylation. Here we have a benzene ring. What's different? Ooh, carbon with a halogen, Rx, aluminum trihalide. Remember, X can be bromine or iodine. And here we make a bond from the benzene ring to the carbon and R with the halogen. In this case, 1 carbon, here 2. I got really fun. If we look at E, what's R? A cyclopentane ring. And therefore, you have a benzene with a cyclopentane ring. We look at F, sulfur trioxide, sulfuric acid. You put on a sulfonic acid group. Remember, don't forget the H. Common mistake students make, they just put SO3. There's no such group. I mark it wrong. Next, HNO3, nitric acid, H2SO4, sulfuric acid. This is nitration. Remember, NO2 is a nitro group, not NO3. That's a common mistake on test number 1. And with that, we're done. Any questions on aromatic compounds? Going once, going twice. I guess we're done. Oh, by the way, don't forget, the next time you smell cinnamon, you're smelling an aromatic compound or tasting it too. Or the next time, and one of my favorites, if you're smelling or tasting something with vanilla extract in it, vanillin is what you're smelling, and that's an aromatic compound. Amazing what Mother Nature has created. All right, since there's no other questions, I'm going to go back to alcohols and start working on that chapter again. Remember, the alcohols chapter will not be on test number 1, but it will be on test number 2 coming up in a couple of weeks. And give me a chance to close some things up. All right, last week, I started talking about alcohols, phenols, and thiols. I do have to warn you, part of this chapter is quite dangerous if you consume too much of it. And part of this chapter is, how should I do this politely, going to stink. I mean, it's going to really stink. So let's talk about alcohols. I mentioned it last time. OH, this is called the hydroxyl group. I'll never ask on a test what's OH, but I'll use that terminology. And you should know that's a hydroxyl group. When you have a hydroxyl group on a carbon, remember R means anything with a carbon, you have an alcohol. And if we look at this molecule, look for what's different, what's not carbon, what's not hydrogen, should get your attention like that. And we've got a oxygen with a hydrogen, OH, hydroxyl group on a carbon. And that's an alcohol. Hydroxyl group on a carbon is an alcohol. Now the question is, how do you name that? And the IUPAC rule is OH hydroxyl group. You change the ANE ending of the longest chain, drop the E, and add OL. And for acyclic, use a number to denote which carbon is the hydroxyl group is on. And that in alcohols, that always gets the highest priority, the lowest number. And the rest of the alkyl groups or whatever follow the IUPAC rules we've already done. But remember, the hydroxyl group has highest priority, which means it gets the lowest number. So if we look at this molecule, there's only one chain. How many carbons are there? 1, 2, 3, 4, 5. That's pentane. Remember, this is test number 2 material. For an alcohol, drop the E, replace it with OL plus a number. So drop the E, replace it with OL, and this is now pentanol. And you start from the chain, end of the chain, that would be carbon 2. if I start from this side, 1, 2, 3, 4, which is smaller, 2 or 4, and times up. Hopefully you figured 2. So that is 2 pentanol. Find the longest chain that contains the hydroxyl group. Name it as an alkane. Drop the E, add OL, then a number. 5 carbons pentane, drop the E, add OL, pentanol. It's on carbon 2. And the alkyl groups are covered the same as you've done in the past. And here's one for you to try. What would be the IUPAC name for the following molecule? 3 points each. And I'd like to thank you all for voting in the poll. Let me know when you're done. And it looks like everybody's done. So let's get to work. If we look at this molecule, look what's different, what's not carbon, what's not. Ooh, oxygen with a hydrogen on a carbon. And that's an alcohol. And how do we name it? We find the longest chain with the carbon with the hydroxyl group. 1, 2, 3, 4, 5, or 5. So that's pentane. Remember, nomenclature for alcohols, find the longest chain with the hydroxyl group OH, name it as an alkane, drop the E, add OL, that's OL, and plus a number. Which carbon is it on? So here, 5 carbons, pentane, pentanol. This is carbon 1, that's 1 pentanol. That's 1, that's 2, that's 3, that's 4. So CH3, you know it's your old friend, the methyl group. And it's on carbon 4. It says 4-methyl 1-pentanol. Oh, let's do another one. These are fun. And again, let me just fix up that hydroxyl group, make it look nicer. Now I feel better. Hopefully you do too. Give the IUPAC name for the following molecule. Your turn. Isn't it nice? I shared a fun. I just realized, Louise, I no longer have a hoodie. I used to. I just have some nice warm hats. All right, everybody's done. So it's my turn. Look for what's different, what's not carbon or hydrogen. Ooh, oxygen with an H on it, hydroxyl group on a carbon. It's an alcohol. And how do we name it? Find the longest chain with the hydroxyl group, name it as an alkane, drop the E, replace it with OL plus a number. And how many carbons longest chain? 1, 2, 3, 4, 1, 2, 3, 4, or 1, 2, 3, 4. Either way, it's 4. That's butane. But it's an alcohol, so I'll drop the E, add OL, butanol. And this is carbon 1, this is carbon 2, 3, 4. If I went the other way, that carbon with the hydroxyl group would be 3. No, you give it the lowest number. So it's 2-butanol. So as soon as I say that, that's spoken for. And we have not 1, but 2 of your old friend, the methyl group. Remember, di, 2, tri, 3 of the same group. So it'd be dimethyl. Now, as soon as you see di, that means you need 2 numbers, even if they're on the same carbon like this. So this would be 3,3 dimethyl 2-butanol. How do we do that? Found the longest chain with the carbon with the hydroxyl group, name it as an alkane, butane, drop the E, replace it with OL, and then a number. Butanol, carbon 2, and carbon 3. There's 2 methyls, dimethyl, so it'd be 3,3-dimethyl 2-butanol. Hopefully none of you did organic chemistry with your friends, neighbors, or loved ones at a Super Bowl party yesterday. I didn't. You lose friends real quick. All right, what I don't have a slide for, so I'll do it the old-fashioned way. For a ring, and an alcohol, name the ring as a cycloalkane. And here we have 6 carbons, OH group on there. That's cyclohexane. Remember, don't forget the cyclo. It's an alcohol. Drop the E, add OL. Now, for a ring, when it's the only functional group, which in our case it will be, no numbers needed, and the carbon with the hydroxyl group is carbon number 1 in numbering. So when you have a ring with something else, when there's no nothing else on the ring, name it as a cycloalkane, drop the E, add OL, and the carbon with the hydroxyl group is always number 1, and we don't write that. It's written with 1 or 2 T's. Well, if I made a mistake, correct it on your notes. Now, if we look at the following molecule, the question is, what's the IUPAC name for the following? And we look for what's different, what's not carbon, what's not hydrogen. Ooh, oxygen with a hydrogen and a carbon, that's an alcohol. And here you name the ring as a cycloalkane, drop the E, put in OL, and no number. Because that carbon is always number 1. If that's number 1, on carbon 2 is an ethyl. So first of all, 6-membered ring, cyclohexane. It's an alcohol, drop the E, add OL, cyclohexanol. And on carbon 2 is an ethyl, so that's 2-ethyl cyclohexanol. Now, one thing I should have mentioned for test number 1, and it's true here, you only use ortho, meta, and para for benzene, aromatic compounds, not cyclohexane. This would not be orthoethyl cyclohexanol. No, ortho, meta, and para are only used for aromatic compounds, which this is not. All right, here's one for you to do. Give the IUPAC name. Hold on. I'm having a bad OH drawing day. That's better. Give the IUPAC name for the following. 3 points each. When you see me looking over here, I'm looking at the polling to make sure everybody's done so I can continue. Boy, I just looked at the clock. Boy, time flies when you're having fun with alcohol. Oops. I shouldn't have said it that way. All right. Look for what's different, what's not carbon, what's not hydrogen. Ooh, an oxygen with a hydroxyl group on a carbon. It's an alcohol. And name the ring as a cycloalkane, drop the E, add, replace it with OL, and no number is needed. Well, how many carbons? 1, 2, 3, 4, 5. It's a ring. 5 is pentane. A ring is cyclopentane. But I'm going to drop the E and replace it with OL, cyclopentanol. and I'm done, because you don't need a number for the hydroxyl group, no matter what carbon it's on. And why don't you do this one? Give the IUPAC name for the following molecule. And please be patient and try and give everybody time to finish. And you don't have to vote no. I will wait until everybody's done. See, one bad thing about the poll, once you vote no, choice 2, you can't, that's why I didn't even put it in there. You can't redo your vote. All right, looks like everybody's done. We look at this, what do we have? A square? No, that's a ring. How many carbons are there? 1, 2, 3, 4. And that's butane is 4. It's a ring. Cyclobutane. Hydroxyl group on a ring tells me this is an alcohol. And name this cycloalkane and drop the E, add OL, no number, but the carbon with the hydroxyl group is always number 1. So it's cyclobutanol, and I have an N-propyl group here, and you number it in such a way that the hydroxyl group is always 1. If I went the other way, it would be on 4. So you have either 2 or 4, and hopefully all agree 2 is smaller than 4. So that's N-propyl, and it's on carbon 2. So that's 2N-propyl cyclobutanol. And you say, well, what if I call it 1N-propyl 2-cyclobutanol? Nope, 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 nope. The hydroxyl group always has priority, meaning a lower number than alkyl substituents, period. Oh, let's do one more. This is a small alcohol. Now, when you can't have an alcohol and carbon number 2 numbering on a certain molecule alcohol, then it gets no numbering. If wherever you put it, it's always going to be 1, even if it's acyclic, then you don't need a number. All right, everybody's done. We look at this, what's different, what's not carbon, what's not hydrogen, hydroxyl group, OH on a carbon, that's an alcohol. And you find the longest chain, name it as an alkane, and replace with OL. 2 carbons, ethane, and that would be, you can tell I'm an organic chemist. Instinctively, I start putting OH. No, that's OL for the name, ethanol. Now, let's look at this molecule. Same thing. Notice, no matter which carbon you put it on, you have to change the hydrogen, it's always going to be carbon 1. Because of that, this is one of the rare cases, ethanol, you don't need a number because it's impossible to have 2 ethanol. And therefore, this is called ethanol. Now, this is an interesting little molecule. This is the molecule in beer, wine, champagne, and hard liquor that gets people inebriated. That's a fancy way of saying drunk. And in no way am I implying you should ever consume alcohol. That's your personal thing if you're old enough to buy it. Now, I will tell you some personal things. One, I love my vodka. Oh, yes, I do. After yesterday's game, I was happy camper. But because of that, I figured I'll go the next 2 weeks without taking a drink. Now, I like my Grey Goose and Absolute, but to save money, if you go to Costco and buy not their cheap American vodka, but the French, which is, I think, about $26 a liter, 0.75 bottle, and it's got the red glass at the bottom, it's about the same as Grey Goose, which for the same size bottle is about $55. So you save a lot of money, a lot. Now, I also like my wine, and here's a public service. I worked a lot in Germany. Let's see if I can find it real good or quickly. I should have posted. That should help me. Here we go. Everybody see on there the Piers Porter Golden Trachen Riesling Spätlese 2018. I worked in the Piers Porter area where the grapes came for that wine, and it's the best white wine, the Piers Porter. And there are other brands besides this one right here. I can remember having this a number of times in Germany when I worked there. And you'll find German white wines have different kinds. The sweetest is the Auslese, sweet as Spätlese, and not as sweet as Cabernet. And I like the Spätlese and also the Auslese. Back this one right here. And I used to buy this by the case. And here's Auslese. It's a very sweet white German wine. And I like my white German wines much better than French white wines. That's just my own preference. But part of the reason memories, and also I like the taste. And Binny's always has a good selection of German white wines. Well, again, ethanol is the molecule found in beer, wine, and hard spirits. Now, another place you can find ethanol, this molecule, if you drive into your local gas station, and you'll see by the gas pump, there's a little sign, sometimes black lettering on a white or background or black with the white lettering, and says this gasoline contains up to 10% ethanol. And that's that little molecule. And the next time you're in a gas station with a friend, neighbor, loved one, you can say, oh, look, that's the IUPAC name for a small alcohol that has this 2 carbons in it. People don't like hearing chemistry in a gas station. No. But it is put in there. Now, an important little side note. Everybody see on the screen tetraethyl lead? Thank you. And each benzene line here is a carbon. I don't know if they have but it's 4 ethyl groups on lead. And until about, I want to say 1960s or 1970s, outlawed tetraethyl lead in gasoline. This was an additive. And if you were in the 60s and 70s, I started driving one day in the early 70s or late 60s, mid 60s, I take it back. But anyways, all gasolines had lead in it, and it was an additive. The problem was, and it was anti-knock and it helped your engine run better. The problem was when it burned into your engine, coming out of your tailpipe was lead. And you know about lead poisoning. It was in the air and doing harmful things to everybody, causing a tremendous pollution. And they outlawed it. And what they found was a replacement to help your engine run better, anti-knock and other things, was the ethanol. And they put it in, and now that's why you see that on the gas pumps. All right, now, there are 2 types of nomenclature question, and one is give the IUPAC name. The other is or I could say structure. Usually I do say structure. And so the question would be, draw the structure for 2-butanol. I'll do this one. How do you know how to decode this and know what to draw? you start from the right, move left. OL ending. That tells you you have an alcohol, ROH. And if that were E-butane, 4 carbons. And where is the hydroxyl group? It's on carbon 2. Now listen carefully. I learned, and most organic chemists, when it comes to oxygen-containing compounds, they start from the right. It's not, you can start from the other end, but good habits I don't change, and this is a good habit. And therefore, on carbon 2 is the hydroxyl group. OH counts as 1 bond, so there's 4 bonds to carbon. And that would be the answer. Now, you could have also written it this way. And let's call this Roman numeral 1, Roman numeral 2, which is the correct answer. They both are. They're identical. Molecules do not stay fixed on a piece of paper. They rotate. If I said, here's my left hand, I said, close your eyes. I went like that. Oh, look, something different. You go, oh, come on. You just rotated 180 degrees. And that's what I've done going from here to here. Now, I'm going to always write it this way, starting from the right. But on a test, this would be perfectly correct answer. On my answer keys, this is the way I'll do it also. Speaking about it, it's time for a break. Boy, time flies when you're having fun with alcohol. Oof. I'll see you in 5. Let's get going. Welcome back. Again, quick public service announcement from the management, me. Don't forget, on Wednesday after class, I will be sending out the password for the password protected PDF file that's now on D2L for test number 1. You'll have until Thursday, 4 p.m. to do test number 1, and then upload your answers as a single PDF file. If you don't have a printer, just on a piece of paper, write down your answers. You do not have to write down the questions, and upload that. One other thing, and by the way, thank you everybody for handing in lab number 1, the melting point lab. I've graded it. Sometime tomorrow I'll upload your scores for lab 1. And after I do that, I'll remind you, anytime I grade something, I give back to you. Unfortunately, the way I do the labs and tests, I can't really mark why this is wrong, just that it was wrong, or I just take off a point on quiz labs for each question wrong. Anything I grade, if you want to know why you got that score, ask me. Because as I've said a number of times now, there are no such thing as a dumb question in my class, and that includes asking, why did you take all points here? Why did I get that grade? I'll always be happy to explain why I gave a score. And if I do make a mistake, I'll correct it. All right. Now we are doing nomenclature, and the question is, draw the structure for the following. And remember, an alcohol, OL ending. So here's one for you. Draw the structure of 3-heptanol. All right, let's continue. How do you decode this? Know what to draw? You start from the right, move left. OL ending tells you it's an alcohol. OH. And if that were an E heptane, that's 7 carbons. And 3, 6, 7, got that right. And where's the hydroxyl group of the alcohol? On carbon 3. Remember, I'm going to start from this side. You could start from the other one. And there are 4 bonds to carbon. And there we have 3-heptanol. Let's do another one. And here's one for you, 2-T-butyl, 1-decanol. Remember, all this material on alcohols is for test 2, not test 1. All right, looks like everybody's done. So how do you know what to draw when you see the name 2-T-butyl, 1-decanol? You start from the right, move left. OL ending. That tells you it's an alcohol. If that were an E, decane, 10 carbons. And that's 10 carbons. Where's the hydroxyl group? On carbon 1. You have it pointing down or to the right. And if this is 1, this is 2, and it's got a terbutyl group, a T-butyl group. And now I know there are 4 bonds to carbon, so I have to get to work putting in all these hydrogens. Remember, it's your responsibility. If I make a mistake, you should correct me, because I'm working at warp drive. You don't know your science fiction? And if you look at the screen now, we have 10 carbons. On carbon 1 is our hydroxyl group. On carbon 2 is T-butyl group, and we're done. No, we're not. Let's do another one. And why don't you draw the structure for 2-ethyl 4-isopropyl cyclohexanol? Ooh, that's going to be a pretty molecule. And don't forget, Tuesday and Wednesday at 6 to 7:15. I'll have my office hour. If there's a better time you'd like to suggest, let me know, and I can always change it. And if enough people ask for a different time, and you can always email me with a question too. I check my email, kwhite@elgin.edu, at least twice a day, very early in the morning and later in the afternoon or early evening. And when I mean early in the morning, I mean anywhere from 6 a.m. to 8 a.m. Today I actually slept in late, so almost 7 o'clock. Well, I was up late too. All right, looks like everybody's done. So how do you decode this to know what to draw? You start from the right, move left. OL ending, alcohol. Hydroxyl group on something. That word E, cyclohexane, is a ring. And most of you are going to put the hydroxyl group there. On carbon 4 is an isopropyl, carbon 2 is an ethyl. The hydroxyl group is 1, always in a ring, with no other functional groups. 2, 3, 4. You know something? That's better. So on carbon 2 is an ethyl group, and carbon 4 an isopropyl. Says 2-ethyl, 4-isopropyl cyclohexanol. Oh, that's a nice looking molecule. Now you know I'm an organic chemist. All right. And that's how you do the IUPAC nomenclature of alcohols. Now, alcohols have been around for eons. I don't know who was the first to start making alcoholic beverages, the Egyptians or even earlier, but alcohol has been around for a long time. And they're common names. We're getting into some next couple of chapters, very key functional groups that have not only IUPAC names, but common names. And common names are still being used in products you buy. You pick up a jar or a bottle or whatever, and you look at the ingredients, you will see a lot of times the common name, not the IUPAC name. And the common name for alcohols is derived by naming the chain the hydroxyl group is on as an alkyl group, and then adding the word or the name alcohol. Ooh, see word for ethyl alcohol, isopropyl alcohol, T-butyl alcohol. Now, one thing on tests, and I don't really have it on, yes, I do, on tests, I will never ask you, here's the structure, what's its common name? No, I'll never do that. I'll ask you what the IUPAC name is, but not give the common name. What I will ask you to know how to do is, if I give you the common name, you should know how to draw it. Again, on a test, I won't ask you what is the common name, but what I will ask you is to be able to draw the structure from the common name. Why? Because this way, if you see it on a label or something, the rest of your life, you'll know what the structure is. So let's look at a couple. And by the way, switches on for this stuff, what I'm doing. All right, let's look at these three molecules. And if we have the IUPAC name, the first one is ethanol. The second one, the longest chain, 1, 2, 3, propane, and it's an alcohol, propanol, and it's on carbon 2, 2-propanol. And I apologize because I forgot the hydrogens. At my level, we usually don't even put in the hydrogens because everybody knows how to do that, but that's not right for you. If we look here on the last column, the longest chain is 3, hydrox group is on 2, and you also have a methyl group. So this would be 2-methyl, 2-propanol. Now, if I look here, what's that R group? On the first one, the R group is an ethyl. So the common name would be ethyl, name the alkyl group, and then add the word alcohol. And that's ethyl alcohol. If you look at a label and see ethyl alcohol, that's ethanol. Where do you see a lot of times ethyl alcohol? On bottles of wine. For some reason, they don't use ethanol, they use ethyl alcohol. Now, if we look at this compound, what R group is that? 3 carbons, center carbon bonded to something? That's an isopropyl group. And since it's an alcohol, the common name would be isopropyl alcohol. And if you take anywhere from 70 to 90% isopropyl alcohol, and the remainder, anywhere from 10 to 30% water, the product you get is homogeneous. That means it's the same throughout solution. We call rubbing alcohol. And when the pandemic started and hit hard, one of the first things that disappeared from the shelves of stores was rubbing alcohol, because this was a good disinfectant for COVID-19. And not that I get any kickbacks from this company. I wish I did. If you see, they have 70%. And a couple of years ago, they started making 91% isopropyl alcohol. And this is known as rubbing alcohol. Same thing. I don't know why they have two different labels to it. Now, personal story. How many of you are old enough to remember, and give me a thumbs up if you can, back when you went to a doctor's office and they had the glass thermometers they put under your tongue? Any of you remember that? And when you went there and they did that, oh, does that taste bad? Ugh, ugh. But anyways, why did it taste bad? Because if you went to any doctor's office in the examining room, they have, it was sort of like a conical shaped glass that had a thermometer in it. And in there was a liquid. And what was the liquid? Rubbing alcohol, because it killed any germs on there. And they'd take it out, wipe it off with a cotton swab that was sterile, so you didn't get any germs from other things, and stick it under your tongue. Now, why do they call it rubbing alcohol? I have no idea, other than you can rub it on your skin to disinfect it and have some medicinal properties. But that's isopropyl alcohol. And where did they get the name isopropyl alcohol on there? From the isopropyl group in that molecule. Oh, when I worked in industry, there are two types of molecules you use to clean organic chemistry equipment, glassware. One is acetone. I'll teach you about that later in the semester. And something that's less expensive and used more in industry than academics is isopropyl alcohol. And it's used so often, this I'll never ask on a test, but I might say it once in a while, or industrial organic chemists, if I could spell, just call it IPA, isopropyl alcohol, IPA. And when I started first in industry, being the lone person priority and the research group I was in, my job was, in the lab I was in, to go out to the pilot plant and, when it was empty, fill the 5-gallon container of isopropyl alcohol, IPA, we kept in our lab for cleaning glassware, from the 55-gallon drum that was in the pilot plant of the company I was at. Ooh, quick personal thing about this, switches totally off quick. When you're doing reactions in a lab, and I'll talk more about it later on, I'll show you near the end of the semester, I'll take you into actual chemical plant pictures. But anyways, when you're doing reactions in a lab, you do up to a couple of pounds, and then you scale it up. And if you're cooking, if you're making breakfast for yourself or someone else, and you're making scrambled eggs, well, you got your frying pan, no problem. What if you're making it for 10 people? Now you need bigger frying pan or 2 of them, because you've got 10 people you have to serve. And in the chemical industry, we have what's called a pilot plant. I don't know how it got the name pilot for pilot studies, but it is. And there, the scale up is, instead of doing a couple of pounds, you do a couple 100 pounds. And usually that's one drum, which is 450 pounds, roughly, 450 pounds of chemical or more. At that pilot plant, I think you could scale up to, no, it was at another company I worked at, up to 2,000 pounds. And then when you go into a chemical plant and do reactions, you run usually the ones I've always worked at, anywhere from 40,000 pounds up to 240,000 pounds in one reaction. And that's when it starts getting fun. And that's part of what my expertise is in the chemical industry. Oh, for those, I think I mentioned it. If you see a tank wagon, the vehicle that, I like those fancy hand signal. You see something like this at a gas station, they don't show the cab in front where the driver pulls this. This is a tank wagon. These are standardized, 5,000 gallons, 40,000 pounds. And that's a lot of chemical. And here's another one, and it's got a conical. See the ladder on there? When I worked at one company, I also managed the quality control. And before we filled up a tank wagon to ship to customers, my quality control people would have to go up, open the hatch, and make sure it was clean inside with a flashlight. And a couple of times in the winter, when my people, I'm missing someone, guess what? I put on a winter jacket. I remember one time in a snowstorm, which wasn't fun, climbing up there, opening the hatch and finding is it clean. But these are 5,000 gallons, 80,000 pounds. And I've worked in reactions. I've written and managed one up to 4 or 5 of those. That's getting a lot of fun. All right, let's get back to common names of alcohols. Got sidetracked there, but let's get back on track. And the last one you should know, 2-methyl-2-propanol. Nobody ever calls it this. Notice right here, my R group, what is that? A T-butyl group. And this is called T-butyl alcohol. And these are the most common names I can think of. Ethanol, instead of, is also called ethyl alcohol. Nobody ever calls this 2-propanol. Well, sometimes, but usually you're going to call it isopropyl alcohol. Nobody calls this one 2-methyl-2-propanol. It's T-butyl alcohol. Therefore, on a test, if I put down, draw the structure of isopropyl alcohol, you should know how to draw it. Same thing for ethanol, ethyl alcohol, and T-butyl alcohol. All right, let's talk about this molecule. When you have a benzene ring with a hydroxyl group, that's been around for eons. And as they did with benzene and toluene, IUPAC said, we're not going to get the chemists to change the name of that. They call it phenol. Now, you might have heard it called phenol. And I worked for a chemical company that we used, I don't know how many million pounds a year of this. I had a running argument with the chemists in the United States. The European agreed with me, but the American chemist, how many of you have heard it called, I got to think about it, phenol? Well, it's really phenol, but in America, most chemists call it phenol. And this is an interesting molecule. My last patent, I used this molecule with something else to make new products. But phenols, just like toluene, you'd have something phenol. It's like that. And the hydroxyl group is named in there. Now, later on, I'll talk about it, but one place you can find phenol, because it has antiseptic properties, How many are familiar with this nice product that I've been using for years? I don't get any kickbacks. Carmex, stuff you put on your lips when in the winter they get chapped, which mine do. You can tell this has been used. Maybe you can't. But anyways, if you look on the ingredients list on here, one of the ingredients, which you can see, is phenol. See, it's used in your daily life. And when you put that on there, that tingling feeling, that's from the phenol in there. And that has antiseptic properties, which is good for your lips in the winter, at least mine. And let's show you what I mean by this. We look at this molecule. What's the IUPAC name for that? Oh, I've got a benzene ring with a hydroxyl group, and that's called phenol. And good news, I will not be doing enunciation, pronunciation quizzes ever in my class or test. And then here, if this is carbon 1, this is carbon 3, we have an ethyl group. Now, this is considered di-substituted compound. And when you have 1,3 di-substituted, oh, look, someone was nice enough to put this nice table on the screen, and that would be meta. So we don't use numbers here. That would be meta-ethyl phenol. And here's one for you to try. Give the IUPAC name for this compound. Your turn. It looks like everybody's done, so I better get to work. What do we see here that's different? Oh, a benzene ring. Double bonds give that away with a hydroxyl group, and that's phenol. And on this carbon, 4 carbons to the N carbon is N-butyl. Now I get sloppy. Notice I have a capital B there. If you're printing it out or typing it, IUPAC, those should all be lowercase. But this is important. This I don't get sloppy. In the alkyl groups, N should always be lowercase, and propyl and butyl, because we'll learn way down this down the road late in the semester, capital N means something else. Notice this is 1, 2, 3, 4. 1, 4 disubstituted, and that's pure and butyl phenol. And that's phenol. Like I said, it's used in industry. It's used in some of products you purchase. Ooh, one of the nice things about my class, at the end of the semester, you'll be able to take things like this, look at it and say, oh, that's in it. Is it really bad? Is that good? And I'll teach you later on about material safety data sheets so you can look it up and find out. That's the nice thing about having material safety data sheets, also called MSDS sheets or MSD sheets on the internet. All right, everybody. The switch, will this be on the test, is on the off position. Click. But it's still something that I want to talk about because it's an important part of alcohols. And that is alcohols can hydrogen bond. Now, what's a hydrogen bond? It's a weak intermolecular. Inter means between two separate molecules, between non-bonding electrons and nitrogen, oxygen, fluorine, and with the hydrogen on that atom. Water can hydrogen bond. And they are weaker than a singular covalent bond, but their strength has an important, significant effects on key physical properties, such as melting and boiling point, solubility, and water. I'll teach you later on in the semester what I mean by polar solvents. So alcohols can hydrogen bond. Again, switches off. Now, here's an alcohol. The oxygen is more electronegative than the hydrogen. Therefore, this is slightly negative and this is slightly positive. This is the Greek letter delta lowercase, and this means small difference. And we use that in organic chemistry. This is capital delta. And this means large, just regular difference or large difference. So alcohols, there's a slight negative charge on the oxygen, slight positive charge. And if I had another alcohol, which I'll draw like this, same thing. And opposites attract. This is called Coulombic attraction. And this slight attraction here, that's a hydrogen bond. And this oxygen can do the same to another alcohol. And keep on going and going, like the Energizer Bunny, I guess. I don't get any kickbacks from them either. But this plays an important role in alcohols. One of the things bartenders don't like to be taught organic chemistry. You know, that mixed drink you just made me with alcohol in it, you can make that because alcohol hydrogen bonds with the water in that drink. They don't like that at all, not at all. So alcohols can hydrogen bond. Remember, click, switches off. Now, let's talk about, and the switch is still off, but this is something is important. Alcohols are weak acids, but their conjugate base are very strong acid. Now, phenol is a little different. It's a stronger acid than alcohols in general, say non-aromatic alcohols. And this is due to resin stability of the phenoxide anion C board. Again, switches off, but in other classes, you might need to understand this. We have an alcohol, it's in equilibrium where it gives up a proton. And notice the equilibrium arrow, I have it very tiny, I should even write it tinier. Here, this is considered, if you consider an acid, this is its conjugate base. And to go to the right, my right, to this side, it gives up a proton, and a proton donor is an acid. Now, the equilibrium stays essentially here, so that means this, the conjugate base of alcohols, if this is very weak, and it is acid, this is a very strong base. Going from right to left, this called an alkoxide, again, switches off. And yes, there are UPAC nomenclature rules for that. This is a very strong base. It's even stronger than things like sodium hydroxide. And I've used it in my work and research. Now, phenol, and you don't have to copy any of this down because the switch is off. Phenol is a stronger acid. And you see that by the equal equilibrium. This is called the phenoxide anion, which I used in my last patent. And why is this a stronger acid than alcohols? Because I can draw different resonance forms. If I move the electron here, this goes there, and I show it by double arrow. And I can do a couple more. I'll just do one more. Again, switches off, so please don't copy this down. And when you can draw resonance structures, which these are, that makes it more stable. Therefore, it's more stable going here. This, a regular alcohol is non-aromatic. You can't draw the resonance. And this plays an important role. And Dr. White, me, I'm an expert in reactions of the phenoxide anion. Well, it lasted this long. Sorry about that. And we're back on track. All right, switch is still off. We just did acidity. Alcohols can be very weak bases. Again, click, switch is off. Now, what is a base? A Bronsted-Lowry base is a proton acceptor. So if I have an alcohol and react it with an acid, H plus means any acid. It can accept and form this. Let me redraw this. This cation. Now, if we look at this, and the reason I'm talking about it, notice inside the cation we just formed something with 2 hydrogens and an oxygen. 2 oxygen, an oxygen and 2 hydrogen. What would that be? H2O, water. Now, it turns out whenever in a molecule you form a good leaving group, and water is a very stable leaving group, you lose water and you're left with this. And this is called the carbonium ion. About 20 years ago, they now call it a carbocation, which is off. This is the new name, which I hate. I like the old name, carbonium ion, which I'll use. And this turns out to be an important intermediate in some of the reactions I'll teach you. And that's because alcohols are mild base, react with an acid catalyst to make the carbonium ion. Now, how do you make an alcohol? Well, we've already talked about this reaction, and that's if you take a double bond, react with acid and water, you'll form an alcohol. Now, this is the only reaction I'll have both on 2 different tests. I can ask you this on test 1, and I can also ask you this on test 2. That's not what I want. And let me just remind you, remember this is HOH. There's 1 pi bond, 1 sigma bond, break the pi bond, 1 carbon gets H, the other gets OH, and now you know you've made an alcohol. Before I didn't mention it because you didn't know what an alcohol it is, and it follows Markov-Nikov's rule, switches on for this. Now, if I look at the, oh my goodness, we're done. We're done for today. Wow, today went quick. Hopefully it's going quick for you and interesting. Remember, on Wednesday after class, I'll be sending out the password for test number 1. You'll have until Thursday, 4 p.m. to take it and upload your answers. Don't forget, this Thursday is the lab number 2 will be due. If you want to get it on Wednesday, you can do that too. And don't forget, tomorrow night and Wednesday night, I'll have my office hour. And with that, I'll do the Yiddish words that my grandmother always said to me, and my sisters and my parents too. When we'd leave, she'd always say "Gehen gesund," which means go in good health. And with COVID, since it started and it's really not over yet, I don't think, I still wear a mask, I'll say it, Gang gesund. Goodbye. I stole that from Granny and the Beverly Hillbillies. Bye now.